So another in continuation of my last discussion, another set of suggestion I will go through again for .NET application performance only. And so this time it is from Microsoft developer, and he has already given their disclaimer that whatever he is talking with his experience. So please take it as that way only. But he has shared 10 best practices through which you can find, fix, and avoid performance problem in C#.NET application. Okay, this is so let's focus on his concept. Okay, so when to worry about performance. The first question he himself asked, that when to worry about performance. So so in general, like performance optimization is a like premature optimization is the root of all evil, right? So this is the quote given by Donald Knuth, and this is perfectly acceptable, and it is widely acceptable across the all architect whoever is working on architecture design. They assume this, right? That's why they always focus more and more on the completion and then work on optimization. But there are small variation here. So to share this opinion, it is not like black and white things. It doesn't mean that you write your unoptimized code first and then optimize it. This is not Donald Knuth is trying to say. He was just mentioned, or he make this statement because he wants you should not think too much about the performance at the time of when you are starting, because it may create some kind of paralysis, some kind of procrastination for you, and then you will not able to start. Even you will not able to start, then that means you are not able to complete it also, right? So starting is important, complete is important, but meanwhile this is also important that try to write your implementation business logic which is up to mark at least, right? Which is not like basically you should write everything like a junk which is not at all performant, and then you will try to fix it. Maybe it requires to restructure the complete code, and that will be again take almost that many times which you have took in the writing of your implementation, right? So that's why that is not advisable. Here advice is you should monitor many performance related things while development phase also. So that is what this author has mentioned here. He is saying that I very much agree with this approach of like don't focus too much on premature optimization, but he said that with some caveats, and those are, while premature optimization is bad, testing for performance is good. Repeatedly testing response times for your request or measuring execution time of your algorithm is good idea. If it can be done automatically with tests, even better. So I mean, even though like premature optimization is bad, still performance while during development by developer himself is a brilliant idea. But it is, of course, you don't have to put lots of effort for this. If it is possible, write some test cases, unit test to validate regularly on your performance of API. So that could be that is possible, and ideally you have to modify your unit test accordingly if something need to be modified also. But some automated testing or something which needs to test of API logic regularly is very much welcome step here. Okay. The next thing is, while premature optimization is bad, disregarding performance altogether is a folly. Use some basic common sense in your algorithm and architecture. For example, if you have frequently used data that never changes and you keep pulling it from the database, in that case, go ahead with cache it in advance, and this will boost your performance very well. Or at least you should put in some architecture document that this is the reason I am proposing here the caching mechanism is much useful, so that during the development you will come back and handle this optimization, right? And so these kind of things is definitely going to work. Okay. In most application performance issues are not going to be, performance issues are not going to be a problem. Like performance issue is not exactly a problem, but there are specific scenario when you are absolutely do need to worry about performance. And those are, the first point is in a high load server. When your server have lots of high load, like any task which your server is operating which requires high load, in that situation, if your code is not performant, probably it will create lots of bad impact on your server performance also, right? So that's why you should always think about it, right? So in a high load server serving a lot of requests in a high frequency, right? So something like Google search engine, for example, those kinds of servers are where performance matters most. So in that case, optimization can significantly decrease response time or save tens of thousands of dollars in cloud resources, right? So there it is very much required thing. Then the another thing is in algorithms. Optimizing performance of a long-running algorithm can save the user of a lot of time or allow to handle much higher loads. So if you optimize your algorithm, probably it will help you to ROI in your server performance, right? It will increase number of user which your server is taking, and even better to say that number of requests your server is going to handle, it will increase, right? That will increase by optimizing performance of your algorithm. So that's why the focusing on this optimizing your algorithm is very much required thing. But then here the balancing out factor is like sometimes people are thinking very minute level things to implement in higher level language, which is not beneficial in long run, because it definitely going to impact on your scale factor. Because once you start writing raw code without using any abstraction, it will definitely increase your code length requirement, right? So because the higher language is, by providing the abstraction, they are actually making code easy to write, right? So that, and if you write easy code, probably it will be beneficial in maintenance of your code, right? That's why that aspect is also need to be balanced out here. To understand well, developer has to take decision, okay? In a library or a plugin, when you develop a library or a plugin, you are potentially being used in high load server or another type of performance sensitive program. So you are also living in the same process with other libraries and an application is living, right? So your code can be called in hot paths, or you might use too many resources, hurting the overall performance of the process. It is best to plan for the worst case scenario in library and plugin development. So this is a good thought from the author, that not only think about the application perspective, many times it is possible that even though you are a library and plugin developer and you are developing some library, still you have to think about that if your library is putting lots of performance bottleneck in the application which is going to be used, which is going to be to use your library or your plugin, then in that case, it is very much beneficial if you would consider these kind of scenario in your library or plugin code and to optimize your library and plugin at maximum possible level, so that the consumer of your library or plugin would not get impacted of any side effect of your code. Otherwise, gradually your client will vanish. Your client will look around any other library possible which will not impacting their performance. They will take those library and plugin in for their use, right? So that's why when you are providing library or plugin, you should always consider at highest level of optimization possible in your code. Whoever is using your code, they should not get any kind of performance issues because of your library or plugin. Okay, let's move forward. So some of the best practices suggested by engineer here is, first thing he said that it is a very generic statement, but definitely a good way of thinking, especially for performance driven design and architecture. Try to measure everything. Maybe that concept would not require in production environment, but at least dev environment and stage environment. These two environment probably try to measure everything whatever is the possible, because this measurement in terms of metrics will provide you lots of insight of performance related, which will supposed to come in future. So if you start using these kind of concept in your development and staging workflow, you quickly able to see that you are able to remove many issues which is probably will come in prod environment. So this is one suggestion, and this is very genuine suggestion by this author. Okay, so let me go through the word put by this author. When dealing with performance, unless you measure it, you are in the dark. That's correct. There are way too many factors in a .NET program to assume anything without measuring. Right? Again, so this is from the concept is that, like as per the author also, like measuring everything is not an issue, but we have to understand that when to measure, what to measure, and how to measure. So these three factors is very important. When to measure is like for a scenario like high load server, measure request times as part of your regular test. If you can integrate measurement into CI/CD process, if you can, then even better, right? That would be even better situation, because this automatically automates your requirement. So if it is possible, integrate measurement into your CI/CD process. Measure during development when developing an algorithm or a piece of code that is going to be used in a hot path. So yeah, now here is problem with normal developer and good developer or normal developer. So here even author and I also echo with the same, that you don't require to measure everything. Like all things you should not measure. What you will measure is critical path code or any code which is falling under the hot path, hot area, which you think that this would require multiple times execution. This call is multiple. And how you will get that? Like lots of time you can produce these kind of things, which is considered as a bottleneck by using some performance tool or some monitoring tool. So that will give you that kind of minute level bottleneck where they can refer, or he can suggest that this API is called this many number of times. Now this API, if it takes, say for example, just virtual example, if it takes 2 minutes and it is called by like 6,000 times or maybe a million times or 1 lakh times, million times, billion times, like that. So now effectively how much time it is taking, right? So that's why they don't go by numbers in example, because that is little overwhelming. But in general, like if it is giving you some significant penalty and even that significant penalty is happening for one case, it is might be small, but if the same case will be repeated by million times, then this small penalty will give you a bigger impact to your data, right? That's why please try to understand this and then try to solve it. All right, so this is what you should do, and then yeah, so this is what when to measure. This is correct. What to measure is the next point, right? So for development or testing, measuring execution time might not be enough. No, just wait. For development or testing, measuring execution time might be enough. When facing specific performance problem, you can and should measure more metrics. So the author is saying that, and this is perfectly all right, because if there is a performance issue, then the measuring only the execution time is not sufficient, right? In that case, you have to measure more metrics. So with various tools, you can measure an abundance of information like CPU usage, percentage time waiting for GC, exception counters, time spent in a certain method, and more. We will see how further on, right? For a specific problem, you mostly should measure the smallest part that causes the problem. For example, suppose I have an unexplained delay when clicking a button. I will start measuring as closely as possible before the button is hit, and stop measuring as soon as delay is over. This will pinpoint my investigation just to the problematic delay, right? So what to measure is clear out. When to measure, that is also clear. Now how to measure? What to measure is clear, right? What should be your matrix part, and then the next point is definitely how to measure. And under this section, author is saying that measuring performance is best done as closely as possible to a production environment setting. That means measuring a release in release mode without a debugger attached. Release mode ensures the code is optimized, which can make a big difference in performance for a specific scenario. Similarly, attaching a debugger can also decrease performance. Having said that, in my experience, there is a lot of insight to be had when measuring in a debug mode, as well as you just have to keep in mind some of the finding may be due to code optimization and an attached debugger. Okay, so that's correct. That's why it is always realistic if you compare your performance in release mode. Here are some ways you can measure performance. If you are measuring a specific algorithm which can be executed as a standalone method, you can use benchmark.net. It is an open source project that became the industry standard for performance benchmark in .NET. So yeah, this is this is good suggestion, right? Benchmark.net. So benchmark.net is a powerful .NET library for benchmarking. So benchmark.net helps you to transform method into benchmark, track their performance, and share reproducible measurement experiments. It is no harder than writing unit tests. Under the hood, it performs a lot of magic that guarantees a reliable and precise result thanks to the Perfolizer statistical engine. Benchmark.net protects you from popular benchmarking mistakes and warns you if something is wrong with your benchmark design or obtained measurements. The results are presented in a user-friendly form that highlights all the important facts about your experiment. The library is adopted by 14,300 plus projects, including .NET Runtime, and supported by the .NET Foundation. It is easy to start writing benchmarks. Check out example copy-paste version here. So public class this, create, setup, data right, this, and you'll see that this method runtime, mean, error, standard, deviation, and ratio. So method is this, and then runtime is also this, and mean is this, and that. Okay, MD5 .NET and this MD5 performance .NET Core, and so this is your mean, error, standard deviation, ratio. So okay, so I have to go with this tool. As of now, I don't know much, but I will check this definitely. Benchmark.net. Okay, so the tool name is benchmark.net. Going back now, let's go back again, and one is this. Okay, if you are measuring a specific algorithm. Perfect. The second thing is, suggestion here is you can use performance profiler like .trace or ENDS to record a runtime snapshot. Profiling gives you amazing insight. Profiling gives you amazing insight into what happened during the recorded time. We will get back to profiling further on. If you are measuring execution time in code, use the stopwatch class. It is much more accurate than using date timestamp. So stopwatch is much better. So if you are measuring execution time in code, use this stopwatch. Okay, this is the third one, which I am also using in my time performance check. I think we have just done this sample code a few days back. So that is already in YouTube. I have created some video. I will put this in link. So how to check, how to use a stopwatch. It is very simple, not much difficulties in using this. So another is there are profiling tools inside Visual Studio also, specifically the diagnostic tools while debugging and profiling without the debugger. Okay, you must need Visual Studio Enterprise for these features. So yeah, so this is very much good suggestion, and I will prefer to use these things in day-to-day working, right? Especially in development environment. The second thing is start using a performance profiler. So how you will use it, right? Let's read out again. This is good suggestion. Start using performance profiler, because for developer, performance profiler metrics is very important. And if you are able to understand quickly like what exactly is a problem and why this is a problem, then you can quickly able to understand the problem and you can rectify that problem also, right? So that's why it is always recommendable to use the performance profiler in your day-to-day coding environment. And if IDE have this feature, please use it, because that is very much required. That's why it is attached or it is built inside the IDE. So a performance profiler is your SAP knife when it comes to performance. You can use it to detect performance problems and pinpoint to the specific cause. A performance profiler allows you to record a part of your program runtime, save it as a snapshot and investigate it. You will be able to see time spent in each method, time spent on SQL request, time in JIT compile, time in garbage collection, time of various IO request file and network, time waiting for a log to release, time in WPF and WinForms code measuring rendering, time in reflection code. So yeah, so this is what I'm expecting. Few of this is very important for performance point of view to check the real performance of your code. So like time spent in each method, garbage collection, time in SQL request, even it is Oracle database, Oracle SQL request. These are like time for various IO request file and network, right? So these are very important things. You should always use this for your development process, right? It is very much required. Now next thing is, so for example, I'm just trying to use this one. What is this? So it is saying that I don't know what is this, but I definitely want to know. So just like this, okay? So here is a screenshot of dot trace, okay? While analyzing a snapshot, and Microsoft Visual Studio Debugger class glass interpret, get input. So this get input is on time millisecond. So this is significantly, so 28% of reflection. This is giving here, information is given here. So system code, reflection, so almost 28%, right? That is what it is saying. Yeah. So here what we see, the method get input took 22.6 seconds, out of it only 29 milliseconds were its own. The rest were by other method it called. The decompiled source code of the method. The time 22.6 seconds was divided as follows: 36% in system code, 28% in reflection, 21% in WinForm, 10% in user code, 3% is GC wait, garbage collection, and others. So we can further explore the method get input called in another screen. So here we see that get input called another overload method get input, and which called do events, which called event, and so on. We can see how much time each individual method took in millisecond and percentage. In summary, a performance profiler is extremely useful to find and fix performance problems. Okay, mind the GC pressure. The third point is mind the GC pressure. So mind the GC pressure, meaning garbage collection is very much tied to performance, right? I dare to say that the most important thing to understand in a .NET process performance wise is the GC, garbage collector. While allocation are very cheap, GC is expensive and we would constantly keep an eye on it